Three types of analytics. And even though they're all called analytics, two of them actually aren't. So what are the three types of analytics? You've got descriptive analytics, you've got predictive analytics, and you have prescriptive analytics. And like I said at the very beginning, you got three that are called analytics, but the last two, predictive and prescriptive, actually require models. And they require an increasing amount of evidentiary support in order to actually do those types of analytics. Now, why do we call them all analytics even though they aren't? Typically, they're presented to whoever the consumer is in a way that looks exactly like analytics. It could be a dashboard in many cases. And so that visualization has led to the label of analytics, even though they're not. So let's start with the first kind. What is descriptive? And just like the name implies, it describes what's going on right now, or potentially what's happened in the past. These are a lot of times metrics, and this is what companies typically start out with when they're doing their journey down data science. And so descriptive analytics, what's important to understand about them is they are flat. They're just going to tell you, hey, this is what's going on right now. Here it is. Here's what's happened in the past. Here are things that have happened in the past. That's it. That's all they do. They are raw numbers, and they require a person to look at them and then formulate an opinion. Now, they don't support an opinion. That's key to understand. Descriptive analytics do not support an opinion. However, you as a person, you as a human, you as potentially an expert can look at descriptive analytics and find patterns. You can say, I see something here. Here is my opinion about what I see, and I'm going to throw some experience in here, and I'm going to throw some things that, I bring from my background and my education into play here to explain what I think this means. However, remember, that data does not support your opinion. It is simply one piece of a very large puzzle that can make it easier for you as an expert to formulate an opinion about what's going on. And that's the great thing about descriptive analytics. They are so accessible and so easy to consume and use, but they can't be overextended. However, if you're an expert, a lot of times that's what you need in order to determine for yourself, human in the loop, determine for yourself exactly what it is that should be done. However, if you want to now say that the data supports, now we have to do something else, because that initial opinion, the thing you looked at the data and said, I think I see, if that has to be supported by data, meaning you are now predicting an outcome, predicting something that will happen, that requires a higher level of evidentiary support in order for that prediction to be supported by data. So you formulated an opinion. That's a hypothesis. That's great. And sometimes in data science, we use that descriptive data set to formulate a hypothesis with. And it's not typically we look at it and we formulate an opinion, because we're not always domain experts, but we'll build models, and models that are very accurate against new data likely have some great hypotheses in them. So now we have to test that hypothesis. And that means gathering new data. That means creating an experiment and typically comparing multiple models to each other, checking out the performances of multiple models and seeing which ones perform best, and then understanding, kind of decomposing the model to understand what have we actually found? Why is that model performing well? And then validating that we've actually found something, that this model performs better than some random predictive generator or what's in place now, comparing the performance in the real world of our new model that we think is predictive versus maybe something that's already in place. Now that we have a firm evidentiary support for the performance of our model and the predictions it makes, we now have predictive analytics. And you can also see that in the dashboard. That can be presented to a user to identify trends and say, we believe this trend is going to continue. Maybe this trend is going to reverse. Maybe a new trend is emerging. And those are the things that we are going to predict. Now, third type, prescriptive. We're going to prescribe an action. We are going to say, here's what's happening, descriptive. Here's based on that and this new model that we have evidentiary support for. Here's what is going to happen. And now based on what's going on now, what's going to happen, here are some actions that we prescribe. Here are some things that we should do in order to achieve some sort of improvement or objective. And again, this is an even higher level of evidentiary support because we are now recommending policy. We are now telling a business or an individual, or sometimes we're automating something and we want to have a high level of confidence that what our automation is doing will result in the outcome that we want it to result in. And that's prescriptive. Now, what's the higher level than predictive? Well, we now have an additional assertion. We've said this is what we believe is going to happen. We've predicted something, probably predicted a lot of some things. Now we are also predicting the impact of interventions. Now, I'm going to do something, and that's going to be based on this prescriptive model. And that action that I take, that intervention or treatment, as you'll hear in experimental design, is going to cause some outcome or improvement. So that's an even higher level of evidentiary support to say that an action will cause an effect. So those are your three different types of analytics. And you can hear the first one, yes, definitely traditional analytics, but predictive and prescriptive definitely don't fall into that domain that we're used to calling analytics. However, the way that it's presented to a user can look very much like analytics. And that's why we have to avoid the confusion. We have to understand as data scientists that there are increasingly high levels of evidentiary support required in order for us to make a prediction, and then in order for us to prescribe an action with a specific outcome in mind.